It is my privilege to introduce tonight's banquet speaker, Brother Guy Consolmagno, S.J., who is the director of the Vatican Observatory, was curator of the Vatican Meteorite collection, and for many, many years, until his appointment in 2014 as president of the Vatican Observatory Foundation, and then a year or so later as the director of the Vatican Observatory, which is, I'm sure he will explain to everybody, one of the distinguished astronomical facilities and organizations, observatories in the world that has made many significant scientific discoveries, in addition to being unusual in that it is an observatory that is operated by the Vatican. Guy is a native of Detroit, Michigan. He graduated from the University of Detroit Jesuit High School in 1970. Guy studied planetary sciences at MIT. He got his bachelor's and master's there in 74 and 75. And he got his PhD at the University of Arizona in planetary science in 1978. Now, I'm going to intersperse some personal notes here, and you'll have plenty of time to talk. This will only take 25 or 30 minutes. But when I was a graduate student at Caltech, beginning in 1980, my thesis advisor, David Stevenson, had me working on the large moons of Jupiter, the Galilean moons. And one of the papers that he dropped onto my desk was a paper by Consolmagno and Lewis on the interior models and evolution of these very interesting bodies that form a kind of a miniature solar system around Jupiter, in which, of course, Galileo Galilei discovered. So I read the paper, and I was told this was an important paper, and somehow I had formed the idea in my mind that Guy Consolmagno was this distinguished, gray-bearded professor somewhere, when in fact he had basically been a graduate student when you did that work. Master's student, right. So when I met him 2 years later at a conference in Tucson called the Saturn Conference, there was this young guy, really jovial, no gray in his beard, and that was Guy Consolmagno. But obviously I was a prophet because I was having a vision of many decades later, and there's the gray beard. So between then and now, after his PhD at University of Arizona and some postdoctoral work, he served in the U.S. Peace Corps in Kenya, came back to the United States to teach physics at Lafayette College, where he did some very interesting experiments on ammonia water systems at high pressure. And then he entered the Jesuits, which changed his life and our lives, in 1989. He then became a member of the Vatican Observatory in the early 1990s, 1993? 93, okay, good. Guy is a prolific author. He has 200 papers and 6 popular books. But to say prolific isn't really enough, because each one of those books is really different from the others, and every one of them is a joy to read. And they range from a book called God's Mechanics, which is just such an easy read. I read it in a 2.5-hour period on the way to New Mexico from Tucson, all about how individuals who are involved in science and engineering and are people of faith, how they deal with those things. And it's done in such a lighthearted way that it is just a wonderful, wonderful book to read. But he's also written textbooks, for example, Turn Right at Orion, which I'll get to in a minute. Guy has been a strong force in advancing the planetary sciences in the United States. And planetary science is not just a branch of astronomy, it's its own field, which has its own professional society. And in fact, in 2006, Guy served as chair of the Division for Planetary Science of the American Astronomical Society. And that division, what we call the DPS, is the Professional Society of Planetary Scientists. I served in that same role 2 years later in 2008. We overlapped on the committee. I can tell you we all met in Washington to lobby our congressman on planetary flight missions, and I wore my best wrinkled professorial outfit, and Guy was dressed in his sartorial Jesuit suit, and I clearly found myself outclassed at that point. But he led the way into the congressman's offices and got lots of money for us.
One of the congressmen asked, does anybody here believe in God?
Yes, we do. Okay. More importantly, in 2014, Guy won the Division for Planetary Sciences Carl Sagan Medal for excellence in education and public outreach. He is the second member of the Vatican Observatory to win a significant award from the American Astronomical Society or its divisions. And the first of those was Father George Coyne, who won the Van Biesbroek Award from the main society itself, I guess a couple of years before that, around the same time. Guy's Carl Sagan Medal citation refers to his book, Turn Right at Orion, which is a textbook. But this textbook has had an enormous impact not only on students, but also on popular support for astronomy, particularly among amateur astronomers. And it also cites his numerous lectures every year, 40 to 50 every year, although as director of the Vatican Observatory now, you may be dialing back on that, I don't know. But he appears on radio, and he's one of these people who is able to explain not only astronomy, but to explain the relationship of science and faith in a beautiful way, just as we heard from Ken earlier today. People like that have tremendous gift to be able to do that, and we're all grateful for that. And the society, the Division for Planetary Science, concluded their citation as follows, quote, "As a Jesuit brother, Guy has become the voice of the juxtaposition of planetary science and astronomy with Christian belief, a rational spokesperson who can convey exceptionally well how religion and science can coexist." In the 3 decades that I have been personally acquainted with the Vatican Observatory Group and the Jesuit astronomers there, I have never failed to be impressed with their deep but unassuming commitment to all aspects of being a Jesuit. St. Ignatius talked about this indifference, this equanimity that we have to have in life, and all of them exhibit that as they pursue passionately both their science and their faith. And all I can really say about this is this is a kind of a confession, but it's not an official confession. I actually did confess this, but now I'm doing it publicly. So I've helped to organize their schools. Guy kindly offered when they moved from Castel Gandolfo to Albano, and they have these wonderful new quarters, which included a guest apartment. Guy offered it to me when I started a 2-year stint in Italy, and my family was still back in Tucson because our son was finishing up his middle school. So I got to know them really, really well. And it was something that I have to say just really moved me. In fact, my one regret in all this, and this is the confession, is that years ago, when I converted to Catholicism, which was just 10 years ago, a couple of years after that, we were dining in a restaurant with my family in Italy, and leaving the restaurant, Guy pulled me aside, and he expressed concern that somehow my decision to convert to Catholicism might have been unduly influenced by my contacts with him and his Catholic brothers. His Jesuit brothers and fathers. And I replied to him, because I thought this was the answer he wanted to hear, that his concern was actually groundless, that it had nothing to do with that. I actually lied to him, and that's what I wish to confess. So without further ado, I give you Brother Guy Consolmagno.
People wonder, there's a lot of people don't know the difference between a brother and a priest, and so I just remind you, as a brother, I can hear your confession, but I can't forgive you. And I also have to mention the sartorials. This suit used to fit, there's obviously something wrong with it. I bought this at the Vatican department store. And there actually is a department store in the Vatican. I walked in, the guy looked at me, I was significantly thinner. He just pulled a suit off the shelf and said, "This will fit you," and it did. And then he said, "Your Excellency, we have some new bishop robes for you." Going, why made you? Well, you're wearing a bishop's ring. I have had more than one person try to kiss the brass rat. Anyone who's familiar with the MIT ring knows that this is not a bishop's ring, and we'll just leave it at that. I have a talk that I want to talk about which deals with why we do science and what it is to be someone doing science as a Catholic. But before I get into that, I thought, because a lot of people may not know a lot of the details of the Vatican Observatory, I've got a short film that we've put together, narrated by somebody who can explain the Vatican Observatory much better than I can. Oh, it's supposed to have a short film? What happened? No short film. Go back. I wonder if I just, guess what? No short film. Great. If you go online, YouTube, Vatican Observatory Foundation, there's a short film. You'll see it. You haven't missed anything. This is what happens when, let me start with this one, because this is a meteorite. And meteorites are wonderful. Meteorites are my life. I went to MIT because they had the world's biggest collection of science fiction. And I had to choose a major. I chose planetary science because I thought that was astronomy. I found out it was actually geology. You know, going to spend 4 years studying rocks. And then I found out there are rocks that fall from the sky, and I was captured. So I show up at the Vatican, discover they've got the 20th largest collection of meteorites in the world. Now, is that one of the biggest or what? It's a good collection. It's a little bit of everything. Not enough that you could actually pull them apart and do destructive experiments on them, but perfect if you could do a survey of the physical properties. Nobody had ever measured physical properties. And so for the last 25 years, we've been measuring density and porosity and magnetic susceptibility and a lot of the other physical properties that describe how a meteorite's put together. And it's a lot of fun because, among other things, you get to handle the meteorites. One of the projects I've been involved in recently is a way of measuring the meteorite's thermal heat capacity. Now, the way you measure conductivity is with one of these gizmos where you cut it into a tiny bit that's maybe a few millimeters across, and it involves cutting up the meteorite. Most of the ways that the professionals measure heat capacity is to make a tiny disk of material. And it's so sensitive, you have to do an overnight run to calibrate and another run to actually measure the heat capacity. And you get marvelous data. But meteorites are not homogeneous at that scale. So number one, you have to carve up the meteorite. Number two, you never know if you've actually just got a normal piece or an unusual piece. I wanted a way where I could get the kind of numbers, the rough numbers that I could use to model the evolution of asteroids where the meteorites come from. So this was what we came up with. You drop the meteorite into a dewar. You'll notice that's actually Buzz Lightyear on the other side of the dewar there. We now have a modern one that says thermos on the other side. And the idea is, before you drop in the meteorite, you can see the weight of the dewar is dropping because the liquid nitrogen is going away. You drop in the meteorite, and the weight jumps up by the weight of the meteorite. And then it boils away really fast until the meteorite is at room temperature. And you measure how much of the liquid nitrogen got boiled off, and that tells you how much heat came out of the meteorite. It doesn't hurt the meteorite. It gives you a fast and dirty measure. You can do this 4 or 5 times just to make sure and hope that the various errors will average out. Now, one of the issues that people talk about is, first of all, where are you going to get the liquid nitrogen? I'm a theorist. It turns out that about 2009, we moved out of the Papal Palace into the Papal Gardens, and we're next to the dairy farm. Or as they say in Italian, dalle stelle alle stalle, from the stars to the stalls. I don't know how many of you know how cows give milk, but they got to be pregnant or have been pregnant in order to have cattle so that they can, calves so they can have milk. And if you've got a papal herd of cows, the old-fashioned way was to have a papal bull. But papal bulls can be rather nasty, so nowadays it's actually done with frozen bull semen, which means that there's this big tank of liquid nitrogen Next door to the doer that we bought, which we bought through these guys, has the little containers to freeze, bull semen, should we ever need to do that. But, about once a month we go over and borrow a cup of liquid nitrogen. And that's actually the milk that's made at the Papal villas, the milk that goes into the cappuccinos we have every day. Wonder what this was supposed to be. Okay. For whatever reason, that's the modern setup. So we've got the container with the liquid nitrogen. That plastic thing that fits over it is carefully designed to stop water vapor from freezing on top of the liquid nitrogen. It's actually a container that we bought at the €1 store up the road that's designed to store spaghetti. And we just record all the data on the computer there. It's great fun. The one thing that people worry about, you're freezing the meteorites. And as I understand it, that's how you break meteorites up. You dip them in liquid nitrogen. So I actually looked up the original paper, and it's true. You can destroy an iron meteorite by freezing it in liquid nitrogen and then banging at it with a sledgehammer. So as long as we keep the sledgehammers locked up, it's not really a problem. Now, why do we do this? It turns out that knowing the heat capacity of a meteorite allows you to work out the heat capacity of the surface of an asteroid. And one of the big forces that moves asteroids out of their nice stable orbits into an orbit that might be unstable because it's in a resonance with Jupiter or Saturn is an effect called the Yarkovsky effect, which depends on one side of the asteroid being heated up, and then as it rotates, the afternoon side is hotter than the morning side, so it's radiating energy in that direction. So there's a non-uniform radiation of energy, which is enough over billions of years to move an asteroid. And that movement of asteroids might be the sort of thing that would move a near-Earth asteroid into an impact. So the work we're doing will allow us someday to calculate whether or not an asteroid is going to hit us, or how much we have to spin the asteroid to make sure it's shoved out of. And so is that why I'm doing the work? Do I get up on a Thursday morning and say, I've got to do that experiment today or else we'll not be able to solve the problem of the asteroid that's going to hit us in 2047? That's not actually what gets me up in the morning. I can justify this if I'm trying to get money from NASA. One of the cool things is we don't have to get money from NASA. I was describing to someone my new job where my only assignment was do good science. No committees, no classes, no proposals, no tenure, just do good science. If it takes 10 years to put together your table of data, so be it. And my friend looks at me and he goes, that's too good to be true. What's the catch? And I said, well, you do have to take a vow of celibacy. And he goes, my wife's a scientist, she'd understand. So if it's not for deflecting asteroids, why do I actually do it day in and day out? Why do we decide to do some missions and not other missions? We went to Pluto. We went to Pluto in part with the New Horizons missions, in part because the guy in charge of it was a political savvy SOB who made sure that the mission was being funded out of an institution in Maryland where the senator from Maryland was on the committee that had to make the final decision whether to fund it or not. And he played so many political tricks that the DPS at that point went to NASA and said, never again. We're not going to have our missions decided by politics. We're going to have a white paper. We're going to have a book that will decide, what it is that the community thinks is the next thing we're going to do, the decadal report. As it turns out, we saw some really cool things from Pluto, more than we expected. But the mission that we didn't fly might have gone to Europa and might have found really cool things that we still haven't found. Because every mission that you do fly means there's another mission that didn't fly. How are these decisions made? The bigger question is, how do we decide that we're going to be scientists? How do we decide that we're going to do one piece of science compared to a different piece of science? This is College of Charleston, beautiful college, Charleston, South Carolina. A friend of mine for many years has been teaching there now for 20 years or so. She invited me down to give a talk to the students there. I spoke about the moons of Jupiter, and one of the students came up afterwards, and he goes, "That was a really great talk." I go, "Well, thank you." And he goes, "I'm really excited. I want to do that kind of work." I said, "Well, that's cool. I want to be a geologist." Great, that's my background, and it's more than just looking at rocks, let me tell you. And he goes, "Yeah, but what do I tell my mom?" South Carolina, Bible Belt. How can you ask a kid to be a geologist if being a geologist means your parents are going to be ashamed of you because you have rejected the culture, the family, the religion that you were brought up in? If you don't have the support of family to do this work, it's a heck of a lot harder to do it. I didn't realize how lucky I was to have been born into a family where both my parents were college educated, where it was assumed that all of us were going to get advanced degrees. All of us did. And that, the story when I was a kid was not where are you going to go to college, but what are you going to get your doctorate in? And to have gone to MIT so that when I hit the University of Arizona and got some really difficult moments, I could not say, well, I guess I'm not smart enough to solve that problem, but I could look at that ring and go, shut up, go back and do it, because you're good enough. You just are lazy. Incidentally, in science, as we all know, hard work is a sign that you haven't thought through the problem carefully. But I had a friend in grad school who came from a very different kind of family. His dad was a bartender. And when he was running into problems, he'd call home, and Mom would say to him, "Cliff, why are you knocking your head against the wall? You could come home and open a shop and repair TVs. Make good buddy." If that's the kind of support you're getting, it's all the harder to say, no, I'm going to fight past that imposter syndrome that everybody has. I'm going to fight past that sense of insecurity. I'm going to say, yeah, I'm going to stick with it and do it. He did, to his credit. If you don't think that the attitudes of the family and the culture you come from are important, consider this. This is not the picture I expected, but I'll just mention that it was that family that supported me when I decided I wanted to go to MIT. I went to MIT mostly because it had cool tunnels to explore and science fiction. And the decision that I made to go to MIT was in part, and the sense of joy that I felt at MIT.
Is this your family guy?
This is, yes. We're very short. Oh, yeah. I started out as a history major at BC, and I was miserably unhappy because I didn't belong there. And when I went to MIT, I suddenly felt in because I felt like I was part of a community. I felt like I was part of a really exciting place with really exciting people who were all doing really cool things. And I have a feeling being a part of that community was one of the things that supported me and made me love being at MIT and really encouraged me to want to be able to do that science and to do it more. And the pressure you get at a place like Caltech or MIT is not because the professors are on you, but because your own expectations are that you don't want to let down your friends. That sense of community is so important in why we do science. This was the picture I was expecting, if you don't think community is important. I remind you, there is this place in the world you may have heard of called India. There's about 1 billion people who live there. They have been known to have a few mountains in India. You may have heard of the Himalayas. And yet, how many Indians have won a gold medal in the Winter Olympics? Like 0? And it's not because they aren't good athletes. If you play cricket, you know better. But there is not a culture in India where moms want their daughters to be ice skating queens, where dads want to encourage their daughters or sons to ski downhill faster than the person next to them. They don't have the encouragement from family. They don't have the places where they can train to do it. They don't have the competition in their schools, in their communities, wherever. And without that, they can be pretty good skiers, but they're never going to be Olympic class because they don't have that community behind them. Think of that when you recognize the difficulty of getting minorities involved in the science that we do. I look through this room and we're kind of lacking in minorities. Certainly, I don't see anybody here who's African American. And there's something wrong with that. But it's not a matter of fault, it's a matter of what do we do about it? How do we encourage people who don't have the community and the background to get them through the hard parts? Because we all are running into hard parts, and we all need some way of encouraging that. And it's also, I just mentioned that India's got this fabulous history of astronomy, but that's a different talk. What I want to talk about here was another thing. Why do we do this science? Jonathan mentioned that I was in the Peace Corps. When I was in Peace Corps training, we were a bunch of do-good kids, and we were about 80 of us in training, and we learned how to play hacky sack. That's hacky sack there. The idea is you kick it around, and you try to make sure that it doesn't hit the ground, and when you hit the ground, everybody laughs, and then you pick it up and you move it some more. Well, one of our volunteers was from New York City, and her boyfriend came out to visit for a weekend, and he's watching us play hacky sack, and he goes, "I don't get it." You're not knocking each other over? No. You're not trying to steal the beanbag from somebody else? Well, no. How do you win this game? And unfortunately, too much in science, people are more interested in winning the game. But what counts as winning the game? This is PhD comics. And the scary thing is, being a PhD in comics has not changed in the 40 years since I was a PhD. You graduate, world, here I come. Your ambition starts out, I'm going to win the Nobel Prize. I'm going to revolutionize my field. I'm going to get a job at a big university. I'm going to get a job. I'm going to get to that conference in Podunk, Minnesota. I'm going to get to happy hour, or maybe they'll have pepperoni pizza, and that's what counts as winning. What does count as winning? How do you win this game? What are the things that traditionally we say are a sign of success? The approval of others. Science is an interesting thing where it's an economy that's a gift economy. The richer you are, is based on how much you've given away, not how much you've accumulated. If you've got ideas that other people can use and cite, then you're a winner. Getting tenure, sign of success. Getting grant money, getting prizes. One of my great friends who spent time at the Observatory is a professor at MIT, Jack Wisdom. And I love the fact that a guy named Wisdom won the MacArthur Fellowship, Getting your name in the New York Times or Time Magazine or Sky and Telescope, depending on, the local newspaper. I tell students, if you're going into astronomy in order to get rich, it's not going to happen. Outside of Neil Tyson, nobody in astronomy is rich. If you're doing it to be famous, there's no fame in astronomy. And certainly if you're doing it to meet girls, it didn't work for me, What are the reasons? What are the things that make you think you succeeded? You've got successful students, but then what makes them successful that you can say, look at that student? A colleague of ours at the University of Arizona had one student who was quite successful until he was arrested for espionage. Details. If your purpose of life is based on how well your students do, you can't control whether your student is going to be a jerk or not. The number of cited publications, the fact that you've got academic freedom. That thing that they told me when I arrived at the Vatican Observatory, do good science, whatever science you want to do. I never had that freedom when I was working on a NASA grant. I could only do what NASA would pay for. And success might have been to be a member of the committee that gets to tell NASA what are the things we want to pay for. But are any of these things ends in themselves? Okay, you're going to the lab every day, and your goal is to get a paper published in Science. This was the table of contents from December 13. So after 5 years, you become an author on the effective collective molecular representations and Brownian motions of colloids in nematic liquid crystals by Tourette et al. So you don't even get your name in the table of contents. You're one of the als in et al. And it's probably important work. I looked that particular paper up. It's been cited 20 times in the 3 years since the paper came out. Is that what you go down? Is that what gets you up in the morning and makes you want to go to the lab? There are a lot of other things. You could say, I do the science because it satisfies my curiosity. I have a lot of pleasure in solving problems. I have pleasure in seeing patterns in the universe. I'm doing it for truth. I'm doing it for love. Are those ends in themselves? And before you say, well, yes, of course, well, okay. If you had list 1 in blue or list 2 in red, and you were about to hire somebody, are you more likely to hire the guy who's got successful students, fame, and grant money, or the one who likes solving puzzles and says he's in love with the truth? And could you blame a committee that chooses the blue rather than the red? Or for yourself, would you sacrifice anything on list 2 to avoid losing anything on list 1? Would you give up the approval of others to satisfy your curiosity? Science is a communal, it's a communal activity. We don't do science. The science isn't done until we've written it up and shared it with other people. Or else you might just as well not have done it. But if you decide to go off on a project that's interesting to you that absolutely nobody else in the world cares about, they will put you as the last paper on Friday afternoon at your meetings. And, the only people who are going to be there are the people waiting for the happy hour. And you won't have that conversation, that sense of community, that, Lord of the Rings fellowship that made you want to be a scientist in the first place. On the other hand, if you only do the projects that everybody else is doing, because at least, they're interested in my results, but it's not something that personally appeals to you, it gets really hard to get up on a Thursday morning and go face the lab again. Would you give up tenure to satisfy love? Or vice versa? If you've got a family to support, maybe your answer is going to be different than if you're 30 years old and single, like I was when I quit and joined the Peace Corps. Would you give up academic freedom in order to satisfy your pleasure in solving problems? Which is to say, if you just like doing the stuff, you're happy to work for a big corporation who will tell you these are the projects we want you to do and will give you a deluxe sandbox to play in. And for a lot of people, that's a good payoff. It's worth doing. But they don't get to choose what the projects are. Some people, that's a relief. I don't have to think of a project to do. Would you give up the chance to be famous just because you're much happier doing what looks like make work of finding patterns over and over and over again? Or maybe working for a 3-letter agency where they want you to find patterns, but your work will never be published and no one will ever know that you did it. Will you give up grant money to satisfy truth? Would you give up truth in order to give grant money? Where is your heart? It's not obvious to anybody that there's a right answer or a wrong answer to these questions, to these choices, and yet all of us have to face these choices. Where is your heart? How do you make the choices? Because the real question is where's your God? Where in these choices do you find God? We've talked all day today, maybe more glibly than we want to admit, about how science is an act of worship, how doing science gets us closer to the Creator. It's all true. But if it's true, it should make a difference in the choices we make about what field we're going to get into, in the choices we make about the work we choose to do, in the choices we make about what answers will be satisfying. I think we've all run into the issue of the grad student who will never finish the thesis because she wants to do one more experiment. And there's always one more experiment. My master's year at MIT, I shared an office with a woman like that who wound up sleeping on an inflatable cushion in the office so that she could be close to finish. And she said, if I'm not finished by the 1st of May, then I'm leaving. And she left with a thesis that was already done in rough draft, but she burned out. She'd lost track of what answer is good enough, what is the goal of what I'm doing, why am I doing these things? What does this choice tell you about the kind of God you worship? Internal motivations aren't enough. There has to be some kind of ultimate criterion. And if you lose sight of that criterion, the work becomes meaningless, and then you don't do it very well anymore, and then you lose everything. You lose the entire thread of what it was you were doing and why you were doing it. To me personally, the word that comes to mind that motivates me, that gets me in the lab every morning, the fun I have handling meteorites, the fun I have playing with liquid nitrogen. That sense of fun really is a sense of joy, because there's also a sense of joy when I see a pattern of magnetic susceptibility versus grain density in a meteorite. And there, plump, 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 are the 3 major kinds of ordinary chondrites separated out. Who would have thought? When you see, and there's 5 people in the world who will care about it, but those 5 people will, and in the meanwhile, I care about it, and it's really exciting. There's a joy that I get when I see something like that in the telescope. Because not only am I able to do science in what I see, I'm also able to look at it and say, that's beautiful. That's astonishing. Hey, I went into science because I liked science fiction, and there's a unicorn. But it's also the case that those ears of the unicorn is a place where a supernova shock has compressed the gas, and at the tip is where there's going to be a disk of gas that will eventually become a solar system, which someday will have planets, which someday could have little green men who will write stories about strange pink-colored people having adventures in some distant planet. It's a heck of a great universe next door. Let's go. I grew up watching paintings covering science fiction pulp magazines. None of them can match the reality. That's a galaxy. It's a few thousand light years across. And another galaxy collided with it, and the gravity of the first galaxy pulled the second galaxy apart, so its stars are now orbiting the center of the first galaxy. And if you think a few thousand light years is too big, well, then here's a meteorite. That little round thing is less than a millimeter across. And it's, seen through cross-polarized lenses. The colors tell you something about the iron content of the minerals. It also kind of looks like a little baby. This is an image we used for our Christmas card one year. It's beautiful, and it's joyful. And not only are the beautiful colors joyful, but the laws, Maxwell's equations that describe how those colors work are also joyful. I did a sabbatical year at Fordham University. Most people who teach do a sabbatical to do research. Because I do research, I do a sabbatical where I can teach. And I was teaching freshman physics, sophomore physics, introductory E&M. mostly because I remember the joy when I learned Maxwell's equations, and I look forward to teaching other kids. I had a really sharp kid sitting in the front row, and we had gotten to the point of Maxwell's equations, and I'd written them on the board, and they were smart enough that I was able to actually convert them into the differential form. And they go, yeah, we can see that. And then I said, okay, you take the derivative with respect to time on this equation, the derivative with respect to space on that equation. Here are some common terms. You mush them together, and you've got a second-order differential of b with respect to time equals some constant times the second-order differential of b with respect to space. And I step back, and I'm about to reveal what this means, but before I can say a word, the kid in the front row looks up and goes, "Oh my God, it's a wave!" Yeah, it's a wave. It explains what light is. That constant tells you the speed of light. It's the equation that allows us to have radio waves. It's that equation that allows us to transmit power long distance. It's that equation that allows us to understand how spectroscopy works. It's that equation that allows everything that's in electronics to work. And not only is it a really useful equation, there is that burst of joy when suddenly you see it and you go, "Oh my God, it's a wave." Not only are the sunsets beautiful, but the equations describing the sunsets are beautiful. I'm going to step back and finish with one story that I hope will combine these two themes, that theme of community and that theme of joy. I was a postdoctoral fellow at MIT, 3 years. MIT, I was the big time. I was a postdoc, so it means I was like a utility infielder in the big leagues, but I was in the big leagues. And that was after 2 years of being a postdoc at Harvard, which means 5 years as a postdoc, which we all know means couldn't get a job. And I'd walk across the bridge from my office in the green building, the tall building sticking up there, to my apartment in Boston, and I'd wonder, why am I doing this? And I'd lie in bed in my apartment at 3 a.m. wondering, why am I wasting my time being an astronomer when people are starving in the world? The Jesuits did that horrible thing to me of like instilling a conscience that came up at the worst possible moment. And I had no answer. What a ridiculous waste of life to be knocking myself out trying to write a paper that 5 people will read. What's the point? And I did not have an answer. And that's when I decided to join the Peace Corps. I was not only much less gray then, I was also a lot skinnier. It's the dysentery weight loss plan. And I went off to Africa. I joined the Peace Corps. I said, well, I'll go wherever you send me. And they sent me to Africa. They sent me to Kenya. And I went to Kenya, and I said, I'll go and do whatever you want me to do. And they said, okay, you got a science background. You can be a science teacher. We'll put you up country in one of these remote schools where there's no windows in the windows and no black on the blackboards. And I go, yeah. Okay, my science can be good for something anyway. And after about 2 weeks of training, they said, well, actually, with your background, probably we should put you in a better school where they actually do have windows. Okay, whatever you want. At the end of training, they put me in the best high school in the country, which in 1983 had a computer lab in Africa, and lasers in their labs, and kids who would go on to the university, and whatever you want. And I stayed there 3 months, and they moved me to the University of Nairobi, where I taught astrophysics to grad students, which I could have done back in Boston, right? Well, I could see kind of the reasoning behind it, because for all of the issues and problems of a technologically sophisticated society, and these are real problems of pollution, problems of alienation with nature, problems of being separated. Nonetheless, a technologically advanced society is the only one we've gotten so far that can feed its people on a regular basis. And in order to have a technologically sophisticated society, you've got to have an educated populace. For that, you have to have schools. For that, you have to have teachers. And the kids I was training, who are grad students at the University of Nairobi, had jobs waiting for them at the Kenya Science Teachers College to teach the teachers, to teach the kids, to raise the level of the... All very good. Ultimately, the stuff I'm doing in astronomy is, going to help feed the population. But that's not why they wanted to learn it. And every weekend, I would go up country. This is the high school where I taught. Oh, apropos of absolutely nothing. I kept going to the high school even when I was at the university and kept an astronomy club going. And one fine afternoon, President Daniel Arap Moi came to visit the school. The school was actually started as an orphanage. And so they have these bright shirts in case the kids run away, they can be spotted. But it was such a good school, it was supported so well, that they decided, the guys running the school decided, as a political ploy, that 5% of the slots would go to the children of the elite to make sure that the elite people would, keep the school going, to have some political protection. So anyway, the president's there, and these kids have designed space stations that they say they could be launched from Kenya. And when the president stops, they explain beautifully how launching from the equator gives you the maximum velocity, and launching to the east over the Indian Ocean means, if something goes wrong, it falls into the ocean and not onto your neighbor, and why Kenya would be an ideal place for, a future space station. And the president is all very amused by this. And after the president and his entourage are moving on to the next display, one of the women in the entourage goes up to one of the kids there who's been explaining this and gives the kid a big hug. And the kid's going, "Oh, Mom, my friends are looking." Kids are the same everywhere. Motivation's the same everywhere. Because I would go up country. I had a little telescope with me. You got to be in the dark skies of Kenya. Of course, you're going to bring a telescope. And I would set it up and give talks at the local schools where my friends were. And we'd set up the telescope in the evening, and everybody wanted to look through the telescope. And, from the oldest men to the little kids, and, they'd see the craters on the moon. I assume everybody here has probably seen craters of the moon through a telescope. We'd show them the rings of Saturn. How many people here have seen the rings of Saturn through a small telescope? How many of you have ever seen the rings of Saturn through a small telescope and not gone, "Oh, wow"? Because that's what you do. Because that's what human beings do. I had a very clever cat in those days, much better at being a cat than I ever would be. But my cat never wanted to look through the telescope. But every one of those kids going, "Oh, wow," was going, "Oh, wow," just the same way as my friends back in Michigan go, "Oh, wow," because that's what human beings do. And if you can share astronomy with people, you're saying, this is something we do. And if you say, "I'm sorry, you can't do astronomy, you were born in the wrong country, at the wrong time, wrong gender, wrong whatever," you're denying them their humanity. But of course, the other side is when you say, "Yeah, you can do that too," not only are you encouraging their humanity, you're giving them the self-confidence that my friend Cliff needed so badly, so that when they face the problems in their life, they're not going to say to themselves, "Well, of course we can't solve them, we're just Africans," which sadly was an attitude that I heard too often. But instead, they'd be able to say, "I am as good as everybody else because I am everybody else." But there's something even deeper than that. There is something about looking at the stars and wondering and asking yourself, what are those things? How does that relate to me? By wondering, where is my place in the universe? By wondering, why is there something instead of nothing? This is essential to feeding your soul. We don't live by bread alone. I'd read that someplace. And that's when I realized that's why you do astronomy when people are starving in the world. That's why you do art when people are starving in the world. That's when You feed that part of your brain that you don't need to just feed yourself. That issue that we heard about earlier today. That's why I do astronomy. And I came back to America. I got a teaching job at a small college and was incredibly happy. This was what I was good at. I broke up with a girl I was dating with in Boston, and both of us were incredibly happy, so okay. I did a little calculation at that point. I was nearly 40, and I thought, if I met the perfect woman and we started a family, I'd be 40, and those kids, they'd be teenagers when I was like 65? No way. That's not going to work. Well, plan B was join the Jesuits. I could teach one of those schools. Of course, I didn't know that a vow of obedience. I didn't get to teach in one of their schools. I was sent off to Africa and eat that terrible food and look at that boring scenery and, mess around with those ugly meteorites. And as I was finally realizing that plan B was really plan A, and describing how I had done this, somebody said, Guy, you went to MIT, right? Yeah. You got a doctorate, right? Yeah. Guy, how much is 40 plus 15? 55, not 65. So I'm a Jesuit because I can't add. Nonetheless, that's supposed to be reminding me of looking at Jupiter, looking at the moon. We are the race that went to the moon. We went to the moon, not just the astronauts, but the people who built the rocket, and the people who fed the people who built the rocket, and the people who educated the people who built the rocket, and the people who built the roads that the pieces that built the rocket had to travel on. The entire culture built and went to the moon. We all went to the moon. This is something that we all share in, because it was, among everything else, wonderfully and beautifully useless. And we shouldn't turn our back on that. I'm reminded of a story when the I think it was LIGO, I think it was the detector for measuring gravitational waves was getting funded, and the head of the National Science Foundation was going to various Congress people to make sure that it would pass. And one of the important senators was a conservative Republican senator from Alabama. Scary, scary, scary. And the head from NASA, the guy from the National Science Foundation is there, and the head of the LIGO project. And the senator says to the head of the LIGO project, is there any practical use to gravitational waves? And the head of the LIGO project says, absolutely none. And then the NSF guys go, no, you can't say that. And the senator goes, well, if there's no practical use for them, then I guess private industry isn't going to do it, so I suppose the government has to. Yeah, that's why we do this stuff. And so that's why I go back to the lab and I plot up my heat capacities and see what they should have been compared to what they really are. And I see that, my gosh, they're separated by different type, and they're all above the line, which is telling me something. What is it telling me? Why are they all above the line? Oh, because meteorites are not pure minerals, because they're weathered. Oh, the distance above the line is a way that I can use to actually quantify the amount of weathering they've experienced. It's an answer to a problem I didn't even know I had an answer to. And I see something like that, and I go, oh my God. Because we live for these oh my God moments. We live for the beauty that the universe can show us. And thank you all for the beauty that you've shown us, each other, today. Thank you very much.